Okay, so today we're going to go through subnetting, just still the basics of subnetting, and let's begin with the required formulas, the formulas that are going to assist us in subnetting. So we have the first one. We have what called if you want to find out the number of subnets, is equal to 2 power any number, maybe p. This p here represents number of, or the borrowed bits, borrowed bits. Then we have the second number of usable hosts. Usable hosts IP, usable IP addresses. So it's 2 power any number still, maybe you can call it x minus 2. So this represents the host bits. Then we have the third one, which is the magic number, which is 2 power, maybe you can call it p, or p, but this time this p here represents the host bits in an octet boundary. Yeah, so those are the three formulas. So this is an IP address. We need to answer these formulas now. So it's an IP address, and these these formulas, they cut across every IP address. In case, let's say you want to get to know the number of available subnets, still you can use this on any address, number of usable IP addresses that are supported by network address, still you can use this. Then if you want to know the magic number, still you can use this. So the formulas, they remain that. So all you need is just to master them, when you need them, how to use them, how to use them to help you drive to the exact answer that you need. So we have our question, so we have our network address here, 192.168.1.0/24. So if you have an address like this one here, all you need to do is just to find the subnet mask, because it's what you're going to use to substitute. Once we have our magic number, then we can use the magic, once we have our subnet mask, then we can use the subnet mask to substitute in this formula. So here, this /24, it simply means that in subnet mask, we have 8 ones here. These are 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then to total to 32. Because this 24 here it is equivalent to this one. This is the total number of network bits in a subnet mask. Now these ones here, they total to 24, and then this 80. So we're going to use this binary number here, this, to substitute into these three formulas of our thing. So if I want to know with this, how many subnet masks, so how many networks available on this network. So I'll just use this formula, which is number of subnets is equal to 2 power ZP, whereby P represents the borrowed bits. The borrowed bits. So we're going to go back to our subnet mask, which is this. Now the borrowed bits, because now we are dealing with this octant here, this. So the borrowed bits here, they are the ones that have encroached, this octant. So right now, there is no any bit that have encroached this portion. So in this case, the bold bits, it's 2 power 0 because there is none. There is none. So it will be 2 power 0, and this gives us a 1. So here, remember, a 1 here, it's not a bit, but it is the number of subnets. So with this address or with this subnet mask, it supports one, or it is it's going to give us only one group of address, only one network address. And that network, of course, it's the exact one that we are dealing with, which is 192.168, then .1.0. Of course, slash 24. The slash 24, it is equivalent to 255 in decimal number. 255 is 5. Then 255, then .0. So this here, it's the same as this. This is what we call a slash notation, and then this is the form that the subnet mask in decimal format. So this and here we're done the first. Then we have the second one. Number of usable hosts is equal to 2 power x minus 2. And then x is host bits. And in our subnet mask, this is what we had: 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4, 5, 6, 7, 8. Then 2, 5, 6, 7, 8. So the host bits here, we are going to consider all these, the zeros. These are the host bits. So it will be 2 power 8, then minus 2. So this, it gives us 256, and you subtract 2, and then you remain with 254. These are hosts, usable hosts. In other words, the usable IP address. Total number of usable IP addresses. These ones here. And then lastly, because this is second, then lastly, we have the third formula, which is magic magic number, or you can call it a block size, is equal to 2 power 2 power what is p. But anyway, so for the magic number here, I can try to use a different, although the app they're the same. Let me see. It's on record. I can change this to something else. So maybe this we can code it M. And then here still let's maintain and record it M. So this M here is host bits, but with a condition. Host bits in an octet in an octet boundary. So here our subnet mask. Remember, answering all these, we're using subnet mask. So meaning that without subnet mask, you're not going to survive. So here 1, 2, 3, 4, 5, 6, 7, 8. Okay, so host bits in an octet boundary. The octet boundary that the boundary that you are actually dealing with, it's this. It's this. So this is our octet boundary. So they're saying host bits in an octet boundary. So we're going to consider all these because they're in the octet boundary. So it will be 2 power 8, giving us 2, 5, 6. Now, what does the magic number mean? It's the meaning, the meaning of magic. The magic number. The magic number is that now, per group, remember what we are doing right now is subnetting. Subnetting. So in subnetting, what you're doing, we are grouping addresses. So in grouping addresses, for example, if I have one, for example, so far, when you look at the total number of usable IP address, they total to usable IP address. Actually, we can go for this. They total to 256. That the IP addresses, they do range from 0, 1, 2, 3, 4, 5, 6, 7, 100, 200, then 255. So now when you're grouping, you are going to count address without skipping. For example, if you want to divide by 2 here, this, it means that the one group, we're going to have 2, say 1, 2, 7. The total number, 1, 2, 7, that is group 1, and then the other will also be 1, 2, 7. Not 1, 2, 7, because if it's 2, 5, 6, they have to be 8. 8, the number. That in this group here, the first group and then the second, are going to have this and then this. Ranging from, this one here, it will range from 0, and then goes up to 1 to 7. And then this other one, it will do the same, that it's from, actually a continuation from 1 to 8, then up to 2, 5, 5. Yeah? That is subnetting. And now this here, this range here, this what you're seeing here, it's what we call the magic number. So the magic number, it's the total number of IP addresses per group. The magic number, it helps us to find the total number of IP addresses per subnet. A group, it's a subnet, or you can call it a network. So a group, it's not a technical name, just my word, but you can call it subnet network. So the question was, when do we need magic number to get to know the size of the network or a subnet? So once you have a subnet mask, then it can actually help you. Now with this case of ours, since our address is 192.168.1.0/24, it means that in this group, because this is a network, it's a network here. So in this network, we have total number of IP addresses as 256. By the magic number, so you have to use the magic formula to find the total number of addresses in that. Then in this this block still here, somewhere we did this 256 by subtracting 2. So this range, what we said, it's from 0 up to 255. Now this one here, it is the network address, is a network address, and then this one here is the broadcast address. That's the reason why we are subtracting a 2. So this 2 here, it's this one here, and then this. Then these other ones from 1 up to 254. Now this is the range. This is the range of usable addresses. Usable addresses. So you need to note that. So if I'm to actually have different subnets here from this address here, whereby we have 192.168.1.0, so I'll keep adding the magic number. So my magic number is 256. So I will add it here. So if I add this on this, it's 256, and in address, I will not write 256. But in counting, I can actually count 2, even more than 256. But since the 25 actually our 25, this is the total. That to get this, you have to include the 0. And once you count 2, if you count 255, then the total it will be 256. So here, once you add 256 on this, then it exceeds the maximum limit. And what does this mean? We're going to increment this, and it becomes a 2, and then this one here is 0. Now this is another subnet. I'm just, right now I'm using the magic number, how to use the magic number. That if I count 256 IP address, then the next address, it will be in another group. For example, let's assume that you are how many? Maybe you're 12 in total. And I need maybe I need 3 groups. 3 groups. So if I want 3 groups, and how many in 3 groups? I need maybe like 5 members. So I will count 1, 2, 3, 4, 5. This is a group. So per group, I expect that each group here, I will have 5. Now I'm dividing this. Here I will have 5. Then still, now that I have 5, we need 6. Actually, can 1, 2, 3, 4, 5. Then here 6, 7, 8, 9, 10. Then 11, 12. So in this other search, because the total is 12, I will have 3. Actually 2. Then here we have 5. Now what I'm trying to write, that the magic number here is 5. 5. We are supposed to have 5, 5 per group. So here our magic number, it is 2, 5, 6. So if I'm to have many subnets here, so I'll get this subnet or this network, add 256, which is the magic, then it will take me to another group or another network, which is the still the same. If I want to go to the other ones, I'll add 256 addresses on this and then get 192.168. Now here 256, it will change this to a 3, then dot 0. I hope this is the example here. It is actually deep enough for you to borrow at least a conceptual idea. So now we need the range of this, because we've stated everything, that if I have 192.168.1.0, this is a subnet. Remember I said the subnet, it is a network, so you can call even this network. Okay. Then we need the range. Now in the range we have first IP address or first host, and then last IP address, then broadcast. So I'm trying to come up with a table to have the range, to summarize the IP addresses. Actually, this is supposed to, okay, so it's subnet, or you can call it network. So the network address, it is 192.168.1.0. Then the broadcast, it's going to be the last. But now, how are you going to get the last? I can actually use the subnets, add 256 on this, so that I get 192.168.1. Dot 2.255. Because if I add 256 on this, it will give, sorry, not this, but it has to, sorry. So it will be 2, then dot 0. So if I subtract the 1 here, it's impossible. I will borrow 1 from 2, and then it comes weighing 256. Weighing 256. So if it's 256, then here I will remain with the 1. Then 256, I subtract the 1, and then remain with 192.168.1.255. So in between here, the usable, this here, the first usable IP address, you add the 1 here. So it will be 192.168.1.1. Then the last usable, now that I have the broadcast, I will subtract the 1 from this and then get 192.168.1.254. So this is the range. So still, I can do the same here. It comes to this. When it comes to this. But our network address, it was this. So here, meaning that you are done. Yeah? We don't need any other. But if you want to proceed, you can go to this. But if you want to use this method that I've used, first get the next subnet. That if it's 192.168 and you add the magic number, now the magic number is 256, it will end up changing this to a 3, then dot 0. Dot 0. So on this, once you have the next subnet mask, then you can subtract the 1. If you subtract the 1, automatically it will give you 192.168, then dot. If you subtract the 1 here, it's a 2. Then a 1 here, it weighs 256. That is why you subtract the 1. And then dot 255. So you subtract the 1 on this to get the last usable, 192.168.2, then dot 254. Even here you can actually say here you have to add 192.168.1, dot 2, then dot 1. Because here on this, if you have a network address, the first usable IP address, you add 1. If you have the broadcast, you subtract 1 to get the last usable IP address. So a quick example here, let's assume that we have 192.168 dot maybe have dot 10.0, but with slash maybe 25. So what does this mean? So you just list the ones, 8 ones, 8 ones, then 8 ones. There are 24 now. So we add a 1, which is this, then plus 7 zeros. See? So once you have this, then you're good to go. We're going to apply this into our formulas. Formula number 1 was number of subnets equal to 2 power borrowed bits. Now the borrowed bits, it will be the network, so the network bits or the ones that have encroached the host portion. Yeah? So we are dealing with this portion. So which network bit that has encroached? How many bits have encroached this host portion? It's 1. So the number of this, or the borrowed bits here, we have 2 power 1, and this it gives us 2. So with this network, or with this network with this subnet, it will give us 2 different networks. 2 different networks that will maintain this, and then come up with 2 groups. It's this maintained, and then we come up with 2 different groups. I hope it's clear. Okay, so the other formula is number of, now since we're going to have 2 groups, then it means that each group, it has to have a specific number of addresses, and it's what we need to know. Number of usable addresses is equal to 2 power x minus 2. X, these are host host bits. Okay, the host bits. So the host bits here, when you look at this, our host bits are zeros. These, the host bits are our zeros here. These ones here. These are host bits. And then this one here, it's the bold bit. This is the bold bit. So it will be 2 power 7, then minus 2. And this gives us 128. Then you subtract 2. And then you left with 126 as the usable hosts. Usable hosts. So each group, because here there are 2 networks, so each network is going to have total number of usable hosts as 126. Then the last formula, uh, the last formula, the last formula, um, the last formula So the last formula, it is magic number. So we need it here. Our magic number or the block size is equal to 2 power m, and m, these are host bits in an octet boundary. So the host bits in an octet boundary, this is our octet boundary, the whole of this. This is our octet boundary. So we need the host bits in this octet boundary, and there are 7. So it will be, or it's going to be 2 power 7, and this gives us 1, 2. So per network, because we have 2 networks so far, we shall have network 1 having 128 total, and then network 2 still having 128. But within this, we have what we call the usable. So the usable, you subtract 2 from this. Subtract a 2, and then you remain with your 126 usable addresses. So if I'm to have the range or the other table, then automatically this is what you're going to have. That subnet, we need a subnet, then the range, the first address, then last address, then so our network address is this. What I didn't mention is that on this, since our binary subnet mask in binary format here is this, and then if we to convert into decimal, then automatically we're going to, or we shall have this. If you convert this, you get 255, then 255, 255. But when it comes to this one here, it will be 128. So this is our subnet mask. This time it won't be a 0. It's 128. So on this, our network, it is 192.168 dot 10, we had 10, then dot 0 slash 25. So to get the other subnet, I will add my magic number. What's the magic number? The magic number, it is here. Here is our magic number. So I'll use that magic number, add it on this. So which is 128. So if I add 128 here, automatically it's going to take me to 192.168, then dot 10 dot 128. 128. So if I want the broadcast, since I have the next subnet here, the next subnet, which is this, I will subtract 1. If I subtract 1, automatically I will get 192.168 dot 10, then dot 127 after subtracting a 1. Then subtract the 1 again here to get the last usable, which will be 192.168.1.126. Then here you add the 1. 192.168.1.1. So this is the range of our first network. Then the second network here. So try to use the magic number and you get the next. Get the next group here. Get into the next group here so that it helps us to get the IP address this side. So if I add the magic number, which is 128, then automatically it will give me 192.168, then dot. Now, if I add 128, it's going to give me 256, and we cannot write 256. So it will be 11 here, because this one here, it has to change. It gets full, and then you keep 1. This side, you remain with a 0. So if I subtract the 1 here, it's impossible. I will borrow 1 from this side so that I remain with 10 again. It will be 192.168 dot dot. So we have dot 10, then dot, because now if you borrow 1, it will actually be, it's going to come 256. 256. So 256 subtract 1, you remain with 255. And then here you subtract the 1, 192.168 dot 1 dot 254. You add the 1 here, it will be 192.168 dot this is a 10, not a 1. Dot 10, then dot 1. After 1, 2, 9. So when you look at this, it's a continuation. We have not skipped anything. It's a 0, then 192. It's a 0, then 1, then 256. 1, 2, 126, then 127, 128, 129, 25, this is 5, 254, then 255, that is it. That we've maintained our 10 here, as you can see. This is maintained, but we have two groups, this and then this, without changing it maybe to 11. So 11 it will come in once this last octant, once it gets full, as you can see it is full. So the next group it will be 11. Yeah. So you can try to work out on this 192.11.0/26. So this is the exercise. I will check actually mark it on Tuesday, so you have enough time to consult YouTube, whatever. So go and deal with this, and you make sure that you certify or you answer all these questions that we've been answering, and then you come up with a table like this one here. Thank you.